Hey, grade 10s. So in today's lesson, lesson 5, we're going to go over the nature of zeros and of quadratic functions. And I actually think, in my opinion, hopefully this lesson should hopefully be okay because there's actually a lot of review from grade 10. It's just a couple of extra things that we're going to add on to it. And some of the examples do get tricky, I won't lie to you. But generally speaking, the concepts are very similar to what you've seen already. Notice that I did not make a video lesson for lesson 4. That is not by mistake. I decided to not do that just for timing's sake. I felt like lesson 4 was actually pretty self-explanatory, I hope, because it was really just going over the quadratic formula and how to solve using factoring and a couple of just different methods you could use, which I think most of you are kind of familiar with now, especially because we have discussed that before, even in this class, right? So I'm going to focus mainly on this lesson here. So we're going to be learning how to find the number of roots or zeros that we have and using the discriminant test and using sketches, and then also how to determine the equation of parabola. So far what we know is that quadratic equations are of the form ax squared plus bx plus c. And of course, when we talk about functions specifically, we're talking about f at x is equal to ax squared plus bx plus c, but that can also be written in factor form, which is a times x minus r times x minus s, or in vertex form, a times x minus h squared plus k. And if we want to switch from standard form to vertex form, we can complete the square. If we want to go from standard form to factor form, we can factor, pretty simple. And if you want to go from vertex or factor form to standard form, then you expand and simplify. And just remember, we talked about this already. If you want to switch between vertex and factor form, unfortunately, there is no easy way to do that. You have to kind of go the long way and switch it into standard form first. And that's what I meant to write there. We wanted to switch it into standard form first before anything else. So recap of key ideas. So what is each form useful for? So standard form is really going to be helpful in telling you what the y-intercept is. It's going to be the c value, and that's quite easy to spot out there. Vertex form, so if we go back to standard form, it's going to be this parameter right there. Vertex form is going to identify the h and k values, and in factor form we can identify the zeros, so also quite easy as well. So if you want to switch you will have to get very good at switching between different forms to find what you're looking for, right? In my personal opinion, I find factor form probably, I would say, the most useful, because if you have it in factored form, you can find the zeros, and if you know the zeros, you can find the vertex, right? Doesn't necessarily go the other way around. If you find the vertex, doesn't mean you know the zeros, right? But if you know the zeros, you definitely know the vertex. So in my opinion, I feel factored form is probably the strongest, because that will help you identify the zeros. But of course, the thing with factored form is you need to be able to factor, right? And that's why I said from day one, factoring is huge, right? That's why we did factoring on the first day, right? I think I mentioned this to you guys. Factoring is going to be an important skill that you're going to use throughout. So you really have to hone that skill. So to find the zeros, there we go again. You factor first, and then you make each binomial equal to 0. And this is actually what's covered in lesson 4. So that's why I didn't figure I had to do another video lesson. This is also covered in lesson 4. So if I want to find the zeros of this function here, that's the exact same thing as the roots, by the way. So if I talk about zeros and talk about roots, another word for it is x-intercept as well, right? If we're talking about the graph itself. It just depends on the context, right? Roots are normally the solution to the equation. 0 just means the function is equal to 0. And x-intercept is just when does the graph hit the x-axis. And by the way, that should be 0 with no e there. So if you want to find the zeros of this function here, we simply let y equal 0. And then this means that we end up getting, and we have, of course, factor it out. So we end up with x plus 0, x plus 8 times x minus 5. And how did I factor that out? I have to find two numbers add up to -3 but multiply to give me -40. So again, we're just using sum and product, right? So two numbers are 8 and -5. And again, this is the simple case, remember, because the leading coefficient is 1. If the leading coefficient wasn't 1, then I would have to multiply, I would have to decompose it, or I'd have to use the Aussie method or decomposition, whatever it might be, right? And then once I find the two factors there, once it's factored out, I simply make each binomial equal to 0. and then I solve. So I take x plus 8 and make it equal to 0. I bring over the 8 to the other side, and it becomes -8. So I end up getting 0 minus 8, which is -8. And of course, x minus 5 is equal to 0 means that x is equal to 5. So what if you can't factor? If you can't factor, then you use the quadratic formula, which we learned about in lesson 4. And I'm hoping you know this from grade 10, because I feel like the quadratic formula is is a really important skill to know. So how do you use the quadratic formula? So what you do with the quadratic formula is you simply take each of the variables in standard form, and again, it has to be in standard form for you to use it, your a, b, and c parameters, and you simply replace them. You sub in the values that for a, b, and c into your quadratic formula. So you simply replace the a, b, and c with the variables that are given to you in standard form. So again, any question that asks you to find the x-intercept, find the zeros without the e, find the solution, solve for x, they're all basically different ways of asking the same question. So if you ever see something that says find the x-intercept, find the 0, find the roots, find the x, it's asking you for the exact same thing, right? So you want to really remember that. So a couple of examples here. So finding the zeros. If I want to find the 0 of this function here, so I'm going to let, again, I'm going to, first of all, make f at x equals 0, right? Because that's what I'm really trying to do there. And I'm trying to figure out when is a function equal to 0. And what I'm going to do now is I'm going to replace my a, b, and c values in the quadratic formula with a is -1, b is -4, and c is -8, right? So I take my quadratic formula and I replace the a, b, and c values with the ones that are given to me here. And just be careful with the signs. So in our case, we have the negative of b. So it says in the original quadratic formula says -b. I'll actually write it out here. -b plus or minus the square root of 4a of b squared. Sorry, oops. Let me erase that. So b squared minus 4ac all over 2a. So what I'm going to do in this case is simply take -4, sorry, the negative, I'm going to multiply -1 times -4, which is going to give me a positive, by the way, and then I have plus or minus the square root of -4 squared minus 4 times 1 times -8 all over 2 times 1. So now I am going to simplify this into 4 plus or minus the square root of -4 squared, which is 16. Be careful with the signs here. So I'm just going to repeat this again. You want to be really careful with quadratic formula. I personally think it's best to multiply all of them together. So I multiply the -4 times the a times the c. And just be careful with signs. A negative times a positive times a negative gives you a positive. So then we end up getting positive 32, which means I can add 32. And then I have 4 plus or minus the square root of 16 plus 32 over 2. And that ends up giving me 4 plus or minus the square root of 48 over 2. And now I just take the square root of 48. I don't have to worry about writing it as a mixed radical. Unless I tell you, if I tell you, then just do that. But in our case, we probably want an exact value, or we want a decimal. So we switch that into 6.94 approximately. And then that means that there are two possibilities. The first possible answer is that I add the square root and divide by 2. And then the other possible answer is that I subtract the square root and then divide by 2. Okay, so there are my two possible answers. And I do the math, ends up being 5.465 and negative 1.465. So that is there are my two zeros. And of course, if I need the two zeros, I could use this. I'm just following up here. I could use the two zeros to help me find the vertex. So if you want to find the vertex, just find the x coordinate that is, find the midpoint between them, right? So to find the x coordinate of the vertex, I simply add the two zeros and divide by 2. So even in a word problem, by the way, you would still add the positive, and even if you have a negative x-intercept, you would still add them and then divide by 2 to find out where the vertex would be, right? That tells you where the vertex is. It doesn't tell you what the maximum or minimum value is, all right? To find the maximum or minimum value, you still have to sub in the x coordinate into the function. So here's another example. So we have 2x squared plus 3x minus 20. And if we want to solve this, we simply let a be 2, we let b be 3, and we let negative 20 be c, right? So it's going to be b, so a, b, c. So we have a2 is b is 3 and c is negative 20. We sub it into our quadratic formula. Again, be really careful with the signs. That's where people tend to make a lot of mistakes. We are simply going to multiply negative 4 times 2 times negative 20. So we multiply these right here. That ends up giving us negative, so 160, so positive 160. So then I add the two numbers in the square root. And when I do all the math here, and I'm actually going to skip a couple steps here, I'm going to go a little faster here. I end up getting two possible answers, 2.5 and negative 4. So there are my two square roots. So you'll notice that the numbers themselves worked out a bit nicer because we actually ended up with a radical that we could take the square root of perfectly. And that kind of indicates to you that you actually could have done this by factoring. So remember, you always want to factor if you can first, and then the quadratic formula is your backup after that. If you tried factoring and you couldn't find two numbers that work, then you try factoring. But factoring should always come first and then the quadratic formula next, okay? It's really important that you don't give up on factoring. I feel like sometimes when people learn the quadratic formula, they give up on factoring. You need factoring, okay? And I want you to understand that quadratic formula, unfortunately, only works for quadratic functions, right? Whereas you're going to learn that factoring is a really important skill that's actually going to be applied to a lot of different polynomial functions when you learn about them in grade 12. So if I want to solve this equation, I'm not going to do it all. I'm not going to solve the whole thing for you, but I just want to start it off. You would first move the 1 over to the other side. And what that does is it makes the equation equal to 0. And then I'd hopefully identify this as, hey, wait a minute, this is just one of the questions we did before. You're just finding the roots or the zeros, which we already know how to do. And what's the only difference? Well, we have different a, b, and c values. So our a value here is 2, c value is negative 5, and c value is negative 1. You sub it into your quadratic formula, and you end up getting your two answers there. And that is how we solve for x in this case. So I apologize if I'm going a little fast, but I just want to skip over to the harder parts of the lesson. So the discriminant test. So in the quadratic formula, you notice that there is a value that is under the square root, b squared minus 4ac. So going back to what you know about grade 10, sorry, even from before grade 10, you know you can't take the square root of a negative number, right? And so this number, this value that is under the square root, b squared minus 4c, is very important. It's actually so important, it's called its own term. It's called the discriminant. So what we notice is that because we can't take the square root of a negative number, we will know whether there is a solution or not and how many solutions we have based on what the value of the discriminant is. So the general rule here is that before you even solve the quadratic, try to solve for the solutions, you can actually check if there even is a solution, because it's possible that there is no solution, right? And again, if you even draw, if I ask you to draw a parabola that has no x-intercept, you can come up with some, right? This is a parabola that has no x-intercept. This is a parabola that has no x-intercept. This is also another parabola that has no x-intercept, right? There's actually lots of different scenarios where that can happen, right? So what we notice is that it's very possible that a quadratic equation could not be solved, or a quadratic function doesn't have a 0. So what you want to do before you even go through all the work of trying to solve it, you want to figure out what the value of the square under the square root is. Because if the value under the square root is negative, then you know there's not going to be a solution, right? And that's the first case scenario. If the discriminant is negative, there's no solution. What if the discriminant is positive? If the discriminant is positive, there's actually going to be two solutions. And why are there two solutions? Because you're going to be adding the square root in one of the scenarios. And actually, we saw that in both the three examples we just did. And then you're going to be subtracting the square root in another scenario, right? So in the last example that we just did here, we can actually see that ourselves. We had the square root of 25 plus 8. which is the square root of 33. And of course, the two possible answers is that we can add the square root or we could subtract the square root, right? So we either add 5.74 or we subtract 5.74, right? So we could obviously saw here that there were two possible answers because we could either add or subtract the square roots there. So what we notice in this case is that if the discriminant is positive, then we know it greater than 0, then there's two solutions. What if it's equal to 0? If it's equal to 0, then there's only going to be one solution, right? And that solution, actually, to be specific, is just going to be negative b over 2a. And if you're wondering, why is it negative b over 2a? I'll show you right now. So it's going to be negative b over 2a because in the quadratic formula, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. But if this right here is equal to 0, hope everyone can see that. If that's equal to 0, then really you're just taking negative b plus or minus 0, right? So we might as well write it as negative b over 2a. So then your solution is actually pretty easy, right? So if the discriminant is 0, then obviously you only have one solution. It's negative b over 2a. So what's the discriminant test for 0? So we looked at discriminant tests for solutions. So now we're looking at the zeros or the roots of the quadratic function. We also call them roots. What if you're looking at, because in the last example, we were just kind of looking at whether you can solve an equation or not. What about roots? So we can also find the number of roots or zeros before you actually solve before actually solving it. So it's the same idea. If the b squared minus 4ac, the discriminant, is less than 0, then there are no zeros. If it's greater than 0, there are two zeros. And if it is equal to 0, there's only one zero or one x-intercept, right? So remember, roots and zeros and x-intercepts are very similar concepts, right? It just depends on which context you're looking at it. X-intercept is on the graph. The zero is the zero of the function, the value that makes it equal to 0, and the roots is basically the solution to it, right? So if there's only one zero, this basically means that the 0 is not only a 0, it's also a vertex. So if you want to draw this out, you actually might be able to see this, that if a parabola only hits the x-axis once, that means that it's going to be a vertex. So it's one of these scenarios right here. So graphically, what this means is, and actually we'll talk about this next graphically. So the first test that we did is the discriminant test, which is when it's in standard form, we're just checking to see algebraically whether the number under the square root is positive, negative, or 0. So what we look at now is that there's a different way that we could test this out. You could actually put your function in vertex form. And then what we're going to be looking at is looking at the direction of the opening. So whether it opens up or down, as well as the vertex. So the rule here is that if the a value and the k value have different signs, so if a is opening up, and I'll draw a picture here for you. So if a is opening up, but the vertex is below the x-axis, then there's going to be two zeros. Or if a is opening down, and the vertex is above the x-axis, then there's going to be two zeros in this case, right? So two zeros in that scenario. So when when a and k have different signs, there's going to be two zeros. If a and k have the same sign, there's going to be no zeros. And I can draw a picture for that as well. So we can notice here that you would have a parabola that opens up, but it opens up above the x-axis. So if it opens up above the x-axis, it will never hit the x-axis there. And if it opens down below the x-axis, then you know it's not going to have it's not going to have an x-axis, sorry, an x-intercept either, right? It's not going to have a 0. So if they have the same signs, that means the parabola opens up above 0 or opens down below 0, then there's no x-intercept or no zeros or no roots, right? And the last scenario, if k is equal to 0, that actually means that it's the same as the x-intercept. And if we think about transformations, what that really means is that you have a parabola that hasn't moved up or down, so it's going to be somewhere on the x-axis. So because it hasn't actually moved up or down, the vertex is actually going to be somewhere on the x-axis, which means that the x-intercept is also the vertex, right? So what this looks like here, and I'll kind of erase this so you can see it more clearly. I feel like these pictures are nicer. You can see here that if the parabola, if it opens, like I said, if it opens up, but the vertex, the k value is below the x-axis, then there's going to be two zeros. And if it opens down, but the vertex is above the x-axis, then it's going to be there's going to be two zeros in that case as well. And then of course, if they are the same sign, so it opens up above zero or it opens down below zero, which is the scenario here, then we notice that there are no solutions. And of course, there's one solution if basically the k value, if the vertex, sorry, the y coordinate of the vertex is going to be zero. So that means that it's going to be somewhere on the x-axis, which means the zero is also a vertex. And that's basically the three scenarios that we can look at there. I wouldn't recommend actually memorizing this. I think it's best to understand it, right? Really, really try to understand this so that you're not trying to just memorize these rules, right? So if you want to determine number of zeros of a function, if in these scenarios, if you're actually just asked to find the number of zeros, you could use the quadratic formula to try to find out what the solutions are, but there's no point in doing that. What I would do is simply use the discriminant test for the first one, since it's a standard form, and you sub it into b squared minus 4ac, and you check if it's positive, negative, or zero. In this case, we take -1 squared minus 4 times 3 times 5. Be careful with the signs. You end up getting -59, which means there is no solution. For the next one, we know that the parabola opens down and the vertex is above the x-axis. And how do we know it's above the x-axis? Because the y-coordinate of the vertex is +4. So again, it roughly looks like this. And again, I'm just going to do a quick little sketch here. This is not a perfect graph. I'm just doing a sketch. I know the parabola looks something like this. It's going to be -1 and 4 for my parabola, sorry, for my vertex, and it opens down. How do I know it opens down? Because my a value is negative. So I can clearly see here, it doesn't even have to be perfect, but I can clearly see here that there is going to be two x-intercepts. I don't need to know what the answer is. I just need to know how many there are. And I can clearly see here that there are two x-intercepts. And if you wanted to solve this one, by the way, this one's actually not as hard to solve. If you did want to solve for the x-intercepts, you simply let f at x equals 0. And we saw this in lesson 4. And all you're going to do is you're going to isolate for x. You're going to bring the 4 over to the other side, divide by -2, and then take the square root, and then simply subtract 1. So you're just going to solve using inverse operations. So pretty simple to, I would say relatively simple to solve, right? And again, we saw an example of that in lesson 4. This is a more complicated example, and I don't know if we'll have a lot of time to go over this because I'm just a bit of a rush. I got to get to the class now, so I'm just going to do this as quickly as I can. If you want to find out what the missing k value here is, this one's a bit more difficult. It's telling you that there are no zeros. So what you want to do is, if you're given a parameter, you simply treat it as if it were the a value. Let's say that we did know what it was. What would you do? You would still sub it into the quadratic formula. So what you're going to do in this case is you sub it into just your discriminant test. So we have b squared minus 4ac. We're going to replace the a value with k, and you replace the c value with k as well. And when we do this, we end up getting this expression right here, -4 squared minus 4 times k times k. And then you want to check, when is this less than 0? So we actually are really checking, when is 16 minus 4k squared less than 0? So what you need to do in this case, it's a little bit more complicated. You want to be able to draw out what this parabola looks like. Well, how do we know it's a parabola? We know it's a parabola because it has a degree of 2. So you want to figure out, what does this graph look like and when is it going to be below 0? So it doesn't have to be a perfect sketch by no means, but I think the best thing to do here is simply, like I said, just sketch out what you know. Well, I know that 16 minus 4k squared will be equal to 0 when I bring the 16 over, and I get -4k squared is equal to -16. I divide by -4, divide by -4. And I know I'm going really fast, guys. I apologize for this, but I just want to make sure I get this done. So square root of 4. So I have positive and negative square root of 4, which means I have two zeros, one at a negative 2 and one at positive 2. And what else do I know about this parabola? I know it's opening down because the leading coefficient is negative 4. So it looks something like this. And again, this is a rough parabola. You can see here, I'm definitely in a rush here. So, so we have the two zeros, negative 2 and positive 2. And of course, I notice next that it's opening down. So we look at this drawing and we clearly can see here that it's going to be it's going to be below 0 when k is less than negative 2 and when it's greater than positive 2. So I know that there's still a little bit more left to go through the lesson, but I'm going to ask that you can go through it on your own. I actually feel like the rest of it is not that bad. Please do your best to go through that lesson, and I will post this later on. Okay, best of luck.